Hello everyone. In this video we will continue to examine topic 2.1 motion, and in particular we will introduce the equations of motion for uniform acceleration, otherwise known as the SUVAT equations. Alright, so there's a set of equations for uniformly accelerated motion. That is motion in which that acceleration is constant. For example, constant positive 3 meters per second, or constant negative 10 meters per second. They are affectionately known in the IB community as SUVAT for the variables that the IB uses to represent what is going on. I'm of mixed feelings about this particular thing. One is, it's nice to have these particular variables. They make for a nice little acronym here, and they make the equations look cleaner. However, they do so by obscuring some things, and we sort of have to deal with that. But what I'm going to do is define the relationship between the variables used in these equations, in the SUVAT equations, and variables that I have introduced prior. And then in the next couple of videos, we will also, after introducing the equations, show where they come from. Okay, so show how these equations can be derived and understood for uniformly accelerated motion. These equations all relate 4 of the following variables to one another. So all 4 equations relate 4 of these 5 variables: the displacement, the initial velocity, the final velocity, the acceleration itself, and the time interval over which the acceleration acts. So, for SUVAT, the IB is going to use the variable s for the displacement. Okay, it is important to recognize that when they use s, they mean a change in position. They mean a displacement. And I do want you to sort of translate that in your head. It means sometimes you're going to have 2 values to find your s, because you're finding a displacement. You're finding a final position minus an initial position, sometimes in a particular problem. They use u for the initial velocity, which is not of itself problematic, and they use v for final velocity. It's certainly easier to write u and v. It just becomes a little bit annoying later when we hit momentum. So you'll see that a little later. But u is the initial velocity in SUVAT notation. V is the final velocity in SUVAT notation. A is the acceleration itself, okay? And t is delta t. It's the time interval over which the acceleration acts. So t in these equations does not mean the time, not really. It doesn't mean like now at 3 p.m. It means the time interval. 4 seconds long, 2 seconds. It's a full time interval. And this is probably the most egregious bit of notation in this set. But in any case, as long as you remember that t in the SUVAT equations is a time interval rather than the time right now or right then, and that s is the displacement rather than the position per se, then you should be okay. One final thing to note, in the equations are vector equations. So even though they've dropped their vector hats, A is a vector. And what that means is that A could be positive or negative, depending on the direction. So could V, so could U, so could S. So all these vector quantities could have a positive or negative value, and you have to pay attention when using those equations. Okay, so given the notation then, the 4 equations in SUVAT notation are as follows. The final velocity is equal to the initial velocity plus the acceleration times the time. Okay, we've actually already seen this one. The displacement is equal to the average velocity times the time. Notice we're taking an average the old-fashioned way here, which we can do in constantly accelerated motion. So this is the final velocity plus the initial velocity divided by 2. That's what this quantity is. Then the total displacement is equal to the initial velocity times the time plus 1/2 times the acceleration times the time squared. And finally, the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. These 4 equations are given in your data booklet, and we'll show where they come from in the next couple of videos. Notice that usually I would introduce them using the prior notation, using the notation that we have used before. And so in that notation, this particular equation, for example, becomes v final equals v initial plus the acceleration times the change in time. This means exactly the same thing as the IB SUVAT equation, v equals u plus a times t, in SUVAT notation. Likewise, 1/2 times v initial plus v final is equal to the average velocity, or the change in position over the change in time, is the same as equation number 2. And then 3 and 4 we haven't seen yet, but if you were to find those equations in, or use the notation that I've introduced for displacement and velocity, you could translate them as well. In the next couple of videos, we will discuss where these equations come from, what they mean, and how to apply them.